is about integrity in database. So, relational database integrity rules are very essential to good database design. So, there is a concept called referential integrity. So, let's understand that. Actually, the basis of referential integrity is foreign keys. So, you have already seen the concept of primary key and foreign key. So a foreign key in one table references a primary key in another table, correct? The primary key for a table uniquely identifies rows in the given table, and primary keys are maintained with entity integrity, foreign keys with referential integrity. So to understand that, let me take you to the example. So in the product table, and this is your vendor table. So in the product table, product code is the primary key, and in the vendor table the vendor code is the primary key. So as these two tables are connected to each other based on the common similar same column vendor code, so the vendor code in vendor table, which is a primary key, is now referenced in the product table by the vendor code, which performs as the foreign key here. So here the primary key in the tables are maintained with entity integrity, and foreign keys are with the maintained with the referential integrity. So what is the meaning of that? So see, uh, so vendor code is a foreign key in the product table, correct? So product code is the primary key. So whatever values or instances in the rows of vendor code column the product table will have, those value must be found here in the vendor table of vendor code column. So let's say you have some value like 245 245 in the vendor code column of product table. So is it an example of a good entity integrity? No, this is not, because whatever values it will have here, it must be present here in the vendor table of vendor code. Hope you understood the concept of entity integrity and referential integrity. Let me take you to here. So integrity rules. So for entity integrity and referential integrity, some documentation is attached. So entity integrity is a mechanism that the system provides to maintain primary keys. Entity integrity is for primary key, referential integrity is for the foreign key. Just remember that. The primary key serves as a unique identifier for rows in the table. Entity integrity ensures two properties for primary keys. The primary key for a row is unique and it doesn't match the primary key of any other row in the table. And see, the uniqueness property ensures that primary key of each row uniquely identifies it and there are no duplicates. These are some of the characteristics and rules of the entity integrity. Uh, so see here, this example, customer and agent code. Okay. So referential integrity is a mechanism the system provides to maintain foreign keys. So the definition of foreign key must specify the table whose primary key is being referenced. And referential integrity ensures only one property for foreign keys. A valid foreign key value must always reference an existing primary key or contain a null. So see here, there are some values see here in the customer table in the agent code. All the values are there, but there is a space which is blank. So let's say this customer doesn't have an agent, so that's why it must be placed with a value as null. If you leave it like this, if you leave it like as blank, it's not a proper database or table following the integrity property. Okay, so any blank values must be placed with null values, and any agent code here in the agent whatever it has, those values can be found in the agent code column of the customer table as well. So these are the integrity rules or concepts. Let me take you to the next concept, that is relational algebra. So as we have tables, so can we do some sort of manipulation, perform some sort of manipulation in the tables? The answer is yes. And what are those? Some of the operations are like this: select, project, union, intersect. Um, Sorry about that. I'm just trying to scroll it. Okay. So here, the select operation first. Let's say you have one original table, and this, after the select operation, this is the new table. Okay. So if you are selecting all the data from the original table, this is the result and new table that you have. Let's say you write a query, SQL query, select only price which is less than $2. So it should yield these two row values with 1.92 and 1.47. Likewise, select only the P code where the value is 311452. So it will only select that single row. So this is your select operation. And this type of manipulation is possible in the databases or tables. Now project actually, this is an unary operator, okay, and it will yield as a vertical subset like a column of a table, column or set of column. So if you say that project price, so it will only yield the price resultant table. If you project only descript and price, it will give you two columns. If you write project p code and price, it will give you the p code and price. So these are the basic operations. Next you have union and intersection. So union, what happens? Union combines all the rows from two tables excluding the duplicate rows. So here in the union operation, it will unite these two tables together, and if there are any duplicate rows, if some rows will come out of that union, then that will be discarded. And there should be union compatible columns. So table shares same number of columns. There is a rule, and the corresponding columns must share compatible domains as well. So this is the rule that you have to follow while performing union. And intersection means refining out or finding out the common rows or records from multiple tables. So intersect function, it yields only the rows that appear in both the tables, common to both of them. And tables must union compatible to yield valid results. So in both the tables, there is only one record which is common to both of them. Likewise, there are two operations, difference and product. Okay. So difference, actually what happens in the difference operation, it yields all the rows in one table that are not found in the other table. It's like a subtraction operation. So all the values from this table will be subtracted, including this value. So that will give you the records. George Jones, suppose it's not here in the second table. Jane Smith, it's not here, but rather it's found in the first table. So the resultant table will have the values that are not found in the second table. That is your difference. The product is basically multiplying each row of the first table with all the rows of the second table. So it yields all possible pairs of rows from two tables. Okay. So next, I will make a different video for the relational set operators.